you always like experience it, it's like really knowing all different methods. Yeah, exactly. Yeah, yours is pretty nice. Do you guys watch Parks and Recreation? So you know, like the Burt Macklin and like the video with Gary Peters when April dresses from like Peterson Russian, like on the pier. I remember that one. Yeah, it was like for a friend of mine just was Burt Macklin, so I just as April's favorite character.
So I saw someone who dressed up as one of the kids, and she had like a picture of like her dad, like that. I don't even know when she was okay.
That was when he's like on Skype server, right? And like in the background, she just like walks in.
All right, y'all. Today we're going to do a topic that I find very exciting because you get a lot out of it by putting in very little. So it's always fun. Very instant gratification. The thing that takes the longest is downloading the software we need. So as I'm beginning to lecture, I'm going to ask you to download QGIS, which is a very easy point-and-click interface for making maps that we'll use today in conjunction with R. So if you just search for QGIS, which is the letter Q and then GIS, you'll find the QGIS website, which is also qgis.org. And on this site, just download the desktop version. It's free, just like R is. And just pick whichever version matches your computer, so either Windows or Mac. Again, most people are going to have 64 bits, so just pick that if you don't know. But 32-bit will always work. This may take a while as we're all downloading it, so just go ahead and get that started and let that cook in the background.
Sorry, what's it called?
It's called QGIS, so the letter Q, it stands for Quantum GIS, and GIS is Geographic Information Systems. Here's the, I don't know if I can make the URL any bigger, but it's just QGIS.
Oh, I got it.
Again, that'll take a few minutes because it's a pretty big download, but you know, it's safe, it's open source, it's free. It's gonna work. Does anybody have experience with GIS doing like ArcGIS work or anything like that? One person, have you used QGIS or ArcGIS in the past? QGIS. Okay. Yeah. So you probably know, just to introduce everybody else, QGIS is just the free version of ArcGIS that has a lot more features. Sometimes you're going to want to use ArcGIS, but I highly recommend using QGIS all the time. You know, your mileage may vary, but I enjoy being able to use it for free all the time. Don't worry about it. So for those of you just joining us, we're going to work with maps today. So if you could please download the QGIS application, qgis.org. If you have trouble, I'll come around and help you during the lab activity. But this is going to help us make maps the easy way. A lot of times we'll do some setup work in R, and then you'll work on your final map in QGIS. And then if you're really going to publish your map, you're going to edit it in something like Photoshop or Adobe Illustrator, or there's free versions of those programs called GIMP and Inkscape, which I use. I'll show you that too if we have time, but QGIS is going to help you do most of the stuff pretty easily. We use it in conjunction with R today. So we're going to make a lot of cool looking stuff like this today and on Wednesday. What have y'all heard about GIS? What have you heard about making maps? Are you interested in making maps? Where are we coming to this topic from? All right, so raise your hand if you want to learn how to. Are you interested in maps at all? Raise your hand if you. All right, so we all are interested in maps. We only have one person who really knows a lot about making maps. As far as I know, does anybody else have map making experience? A little bit. A lot of people have a little bit of experience. I would say, you know, I have a little bit that gradually increased as people ask me to do stuff for them because I had a little bit of experience. So you'll have that experience too. Once you get your toes wet, it's easy to get pretty far with this. what have you heard about GIS? What other things have you heard? Is it easy? Is it difficult?
Getting easier.
Getting easier? Has anyone else heard that it's hard before? Well, we'll see today that I think it is getting easier. I agree. I think it was hard in the past, but I think a little bit of that was overblown. I think people like to specialize in maps and become an expert in it because it's a lot of fun. And then, they're like, oh yeah, maps are pretty hard. You better let me do all the mapping, right? So there's kind of this political economy of map making. Today, you'll see that it's not very hard with the tools that we have available for free. So, I encourage you to be skeptical when you hear someone say making maps is hard. Well, you might be trying to protect their job or something, right? That's been my experience of people who do this. But so why do we want to make maps? You probably have your own reasons. I just want to talk about some of the reasons I like making maps. Number one is it's easy to communicate with maps, especially if you're doing community engagement work or some kind of publication that's public facing. If you ever pick up the newspaper, you'll see maps all the time in news stories. People like reading maps. People can talk about maps. Maps can be a resource people can point to. You can use maps to display kinds of data, for example, community concerns or community exposure, types of data that are hard to talk about with numbers to the public, but which make a lot of sense on a map. So this is an example of a map that I made for my dissertation proposal that has the location of all of the hog operations that use lagoon and spray field systems. So this is all of the factory farms that dump all the waste into huge pits and just leave it there to rot. So what do you notice about this map? What does this map tell you about the locations of CAFOs or ILOs?
Concentrated in the southeastern part.
Yeah. So I could compute a measure of clustering, which is perhaps someone who's specialized in GIS work is going to tell you need to do. But just looking at the map, you can kind of get ideas that are hard to really think about and communicate with numbers, right? So if I told you that there's some sort of spatial autocorrelation factor of 0.79, that's not really going to mean anything to you, right? But you can look at the real data. Perhaps as humans, maybe we're really able to think of stuff this way, this sort of two-dimensional view. But you can see that there's a concentration there, right? And so this is kind of my argument about why this is a public health problem in this area, because there's a lot of operations. So you can easily, maybe I've not done the best job of communicating this particular example, but in general, you can make these kinds of arguments with maps that it's hard to do with other kinds of data. You don't need any kind of scientific training to understand what the map's trying to show you. The second strength is you can use GIS to improve your models. Again, this is kind of back to the political economy of map making. Why do we need to make maps? But I think it can have a role. If you think about observations near each other affecting each other, right? We have this assumption in all of our models that, or most of our models, that individual units of analysis don't affect each other. Right? So if I get vaccinated, it doesn't affect you. It's only whether I get the vaccine or not affects my risk of being infected, for example, in a very simple model. Well, you can use spatial information to determine what units are close together and what units might affect each other. So it allows you to go from this kind of, oh, well, if everything affects everything else, I'm just stuck, right? Well, it allows you to have somewhere to go. You can say, oh, well, maybe people within a mile of each other affect each other. Everyone else doesn't. You can simplify the model enough while remaining some kind of flexibility for interference, that's called, using spatial data. So there's a way you can actually improve your models using spatial data. The third benefit that I see is that you can link data together. And this is how I really use a lot of maps beyond communication. If you have information that's spatially coded, so if I have the exposure distribution for a particular zip code, or I have the number of supermarkets in a county, if I have any kind of geographic tag on my data, that means I can link it to any other data that has that same kind of tagging system, right? So I can link, because these operations have addresses, they're at 3005 Farm Road, Smithfield, NC. I can plot them on the map and also know where people live from the census, right? The Census Bureau tells me how many people live in each block group or each block. which is essentially like a city block, but more general. It's a pretty small area for the most part. Now I can link population data to exposure data, even though no one really did a study about exposure to ILOs that was statewide. I can simulate that by linking together data. So as an epidemiologist, I really see this as sort of the really big thing that everyone can benefit from. Even if you don't do community-facing work or public-facing work, you can do new kinds of analysis by linking existing data, as long as it's spatially coded. The other thing I want you to take away from this presentation is even if you never make a map again, please collect spatial information into your research, because researchers in the future can do all sorts of things with your data. It's going to benefit you too, because people will reference you when they do it, right? But even in that sort of public sense, you're doing a public service by making this available, because other people can answer new questions and get new answers for public health using your data. So if you learn nothing else today, if you decide map making is not for you, please, please, please collect information about spatial or the location of things that you're studying. Keeping in mind you need to appropriately protect individual privacy, right? But you can do a lot more with spatial data often by linking it to existing stuff. There's a whole lot of types of ways people have thought about spatial data. I'm going to introduce 4 major ways you'll see it. For the most part, people stick with the third one, which we'll focus on today, but points are important too. Nobody does lines. So the first type of data is point data. So this is just a bunch of dots on a grid. It's sort of the simplest kind of data. I can imagine if I had a health study, maybe I write down everyone's address and I can plot it on a map later. I'll get into what this is exactly later, but you're going to get a y coordinate and x coordinate for their house on the Earth. That's how you're going to plot the map. This is just like making a scatter plot. If I had blood pressure and height or something, I can make a scatter plot. These kinds of maps are just scatter plots, right? They just use geographic coordinates is the only difference between this and another scatter plot. But this is the simplest starting point. You can probably imagine how you could do this yourself if you just plot the latitude and longitude of someone's house. The hard part is going to be, how do I link an address to a latitude and longitude, right? How do I know? But you all have probably done that before if you ever looked up an address in Google Maps or something like that. You can type in an address, it spits out where it is on the map. That's essentially what's going to happen behind the scenes for you. You don't have to really do that yourself. The second kind of data that we have in spatial sense is line data or vector data. This is really just a set of points connected in a line. What kinds of data might be a common? So I talked about how point data often is going to be people. What kind of data might be represented by lines? When would I have a line as my data type? So each observation here is going to be a line. What's in this picture?
Border?
Yeah, so this is probably, these could be, so these are topography lines. So these are borders between areas of different elevation. That's one, it's a border between units, could be a line. What else do we have here? What do you think the orange lines are?
Roads.
Roads, right. So this is, to go more general, this is a path. So you might have a path that a person goes on their commute every morning. You might have the path of them going to the grocery store. You might have the path of them commuting and taking their kids to school and back. If you're doing a study about traffic accidents, you might be very interested in the paths people take every day because you want to understand what the risks are in different regions. Maybe there's a high risk of certain intersections. So you're going to look at all the paths of all the people who were in traffic accidents and notice that all the paths were going down one corridor, even if they didn't happen in one particular place. You can also see here there's water features. Other kinds of environmental data might have paths, but we don't do this a lot in public health. Third type is the one that we really, really have a whole lot of, which is polygon data. Polygon data, it's kind of like taking the path, but it's forming complete circles to generate regions. This is how most of our population data is recorded. So if we have individual participants, we might have their home addresses, But if I'm doing a census of the population, I would report the number of people within each different region. There's a couple problems that this approach presents. But let's talk about, why do you think we build data this way, right? Like, why, if I was doing a census, why wouldn't I just have one dot for every person in the United States? Why would I group them into, in this example, counties or blocks or neighborhoods? Why would I want to aggregate, which is just taking points and turning them into regions and having the number of people within a region? Why would I aggregate data like that? What's the point? Well, I guess it's not the point, right? You're not having points, but why would I bother? Why not just give everyone? Why not have a file that has everyone's home address in the United States? Any ideas? They do this in Northern Europe? Yeah.
Well, if you're making policies, I guess it would be sort of at a regional level, not individual level.
Right. So in that sense, it provides a meaningful interpretation for what data is, right? So I'm not going to say, everyone who's on latitude 79.9 degrees, you all get free lunches, or your kids get reduced lunch, right? I wouldn't do that. I would want to look at a policy intervention that uses a unit of analysis of a region to inform my analysis. In terms of protecting individuals, why might I do aggregation?
Most times in public health, you want your counts to be over a certain threshold.
Right. So I don't want people tracking down my individual study participants if I can help it. So a lot of the public data you'll see is aggregated. So you'll notice from this picture that when you have polygons in spatial data, they're all different sizes, right? So I've got some of these counties, this is all counties and population growth. Some of these counties look really big. Some of these counties look really small, especially along the East Coast. Why do you think these counties in the West, why are they so big? Do you think it's because, I'll give you multiple choice here. Are they big because there's more people there or because there's more space to count? Who thinks the size in the U.S. Census is based on the number of people in a region? Well, this is confusing because they do it backwards, so it's a bad question actually. But I'll just cut to the chase. So usually, right? Usually maps are not built the way that you would want. So these counties are enormous. They have very low population density. Some of the counties on the East Coast, for example, if you consider New York City, that area, I think they call them boroughs or something, but I don't know if that's a subdivision. But anyways, they're going to have huge population densities, right? Whereas the counties in the West Coast are going to have really sparse population densities. So the point I'm trying to make is maps like this that use polygons are inherently misleading because our minds tend to think about one unit of space being the same, right? So we kind of look at this and we see all this red and we're like, oh, looks like the West Coast is increasing in population. And it looks like the East Coast is not increasing as much, something like that. Maybe this area is, but maybe the Northeast is not, right? But the problem is, maybe there's only 5 people living in this county, these big red counties. If there's only 5 people living here, one additional person is going to be a huge increase. Generally in maps, the larger the unit, the reason why there's a large unit is because they were only counting 5 people in that whole region or something like that, right? I mean, from this example, in the West Coast, things were more spread out, especially in Nevada. Maybe the area around Las Vegas is going to be more dense, but there's this inherent bias in these maps that you need to be aware of, which is that usually the size of the blocks is dependent on population density. So when you look at blocks like this, the ones that appear most on the map, the ones that appear most significant or different, those actually represent the smallest part of the population. So this is kind of like if you've seen those maps that show the world, but it's like proportionally sized based on different factors. Like maybe they have one where it's stretched by income. So, New York City or the United States is like huge, and, Japan's really big too. We might have one where it's adjusted for the true area. So, then the United States looks smaller, for example. But keep in mind that all these maps are kind of distorted and biased based on the size of the units. So it's not as simple as it appears. This is stuff you need to think about when you're making maps. Is try not to mislead people. Try to include as much information as you can to help illustrate what's actually being mapped. So I spent time talking about the bias because this is what most people want to see, and this is how most of our data is collected. It's how most of our results are graphed. Because even when we make publications, we can't show people individual houses. We have to aggregate them into areas so that we can present them that. The fourth type of GIS data attempts to solve the different size unit problem, called a raster. What it is you use a grid of equally sized units of the same geometry. Generally, it's just squares. And otherwise, it's the same as a polygon, except you're using regular units here. So instead of using administrative districts, which are often used for convenience in health studies, so for example, a zip code, which actually that's a service district, not an administrative district. But a city might be, there's some spillover because a city provides services, but also it's an administrative unit. But these are units created by the analysts, which are used for, trying to fix that problem of different sizes. You'll see this a lot for image processing data. It uses the same kind of approach because an image is just a bunch of boxes with computer slots, for example. So you might see raster sometime. We're not going to deal with them as much, but for the most part, you use the same kinds of analysis as the polygon data. But you might do some other background math to account for the fact that you probably have a lot of blocks here that have nobody in them, right? So if it was the woods behind my house, there's not going to be anybody there, but someone's going to have to go out from the census and check that. Versus if I have polygons for each county or neighborhood, I can just drive around the neighborhood and look for people. It's a different kind of way of handling missing data. With polygons, if there's an area without people in it, I include that with other people. And with a raster, if there's areas with no people in them, I include them as zeros in the data set. We have a lot more missing data in a sense using raster data. With polygon data, the missing data is lumped in with your other non-missing data, and that's actually, if you really think about it, that's kind of what's creating the bias. Is you kind of have spatial units that are missing data, and you're misclassifying them as being in one of the groups with data. Let's talk that a little bit today. But I'm going to start today by talking about ArcGIS. Fortunately, you all don't have a lot of experience with ArcGIS, which is great, because you have to unlearn a lot. You know a lot of ArcGIS. Esri, which is the company that makes ArcGIS, just like SAS, they spend a lot of money doing trainings, which is positive in a sense, but also it's this kind of business model where people get locked into it. They start controlling what people think about, what people can do. They start influencing the way science is done. So a private corporation is going to do that instead of perhaps a public scientific community. Certainly, the scientific community is not mean to Kristen either, but point is, we're not going to use ArcGIS, but it's a great starting point. We're going to use a free version of ArcGIS. So I think of ArcGIS as the SAS, and I think of QGIS as the R version. It's really sort of the same idea. But ArcGIS and QGIS are much more similar than R and SAS. So the reason why you need to know about the background of ArcGIS is, number one, is we've inherited this approach. So all the data that you'll deal with is in the format that ArcGIS wants. And it was essentially the first people who had an idea about how to do this. So it's a very bad idea. It is an awful way to store data. This is what 95% of people saying that GIS is hard is because they picked a bad format for the data and we're stuck with it. Right? We'll talk about today how there's some other approaches, people trying to fix it. And fortunately, people in R have made packages that handle it for you for the most part. You still have to learn how to tell it to fix it. But just keep this in mind. Everything you find frustrating is because Esri did a bad job. The reason why they did a bad job is because they were the only people to do it, right? So I'm not blaming Esri. They're running a business, right? They're trying to make money. They have a fiduciary duty to their shareholders to make money, right? But just keep that in mind. When you're frustrated, just be like, dang it, the 5 people at Esri in the 1990s, come on. Can't you all do a better job of thinking about how to store this data? So we'll talk about the data format because you need to understand it. That's, every time you get spatial data, you're going to get Esri files. You have to understand how they work. Maybe in 20 years this won't be the case, but today we're working with this data. So QGIS is essentially the same as ArcGIS. It's open source. It has some more features. There's not, a training exercise. If you're interested in this stuff, I might actually recommend getting training from ArcGIS. This is a good place to start, but there's lots of other resources available too. So it's the same problem with SAS. There's a business that's doing this, so there's a lot of, it's not really corruption, but there's a lot of sort of influence that you're gonna have to deal with. And the file format, while bad, it's really the way you might think about it initially. So it's a good introduction to how spatial data is. Because knowing nothing, you're kind of like, oh, I guess this kind of makes sense, right? Why wouldn't I do it this way? And that's what they were doing back in the day, and it's a good introduction to how to organize spatial data. So I think of shapefiles as the Tamagotchi. I might be older than some of you, not as old as some of you, but when I was a kid, I had this little pocket pet called a Tamagotchi. You would like feed it by pressing the buttons every day, and it would die if you didn't feed it. Everyone has a fad like this in their childhood, right? Everybody wanted it. And today we still have them around, maybe hipsters think Tamagotchis are cool, they might carry one around. So, try and like, really feel that sort of respect for the archaic system here, right? We're pulling a typewriter out of the attic and dusting it off and trying to understand how did people write essays before we had computers, right? They typed everything with their fingers. I've done this a couple times just to understand it. I've used a slide rule for my engineering classes, but this is a real example where you still have to understand it better. Like you don't really have to understand typewriter. Use a computer today, but all right. So I'm a little bit off track here. So there's five files. This is the punchline. Whenever you do a spatial data, there's at least 5 files in a folder, and that's your data set. There's not one data set, one file. There's one data set, 5 files or more. They all have the same name, but they have different file extensions. Sometimes they're invisible because your computer hides them. Sometimes you can see them. So sometimes you get spatial data from somebody and it doesn't work, and you realize, well, they didn't give you all the files, right? This is like the #1 most common problem that I encounter. People download a data file from the internet and they try and work with just the first file because that makes intuitive sense, right? Computers have developed far enough where a lot of people that don't even know where their files are. They don't understand how a file system works. They just click on documents and know their stuff is. They don't understand how anything's organized or where it is on the disk or how a computer finds it. This is another one of those kinds of problems. Just keep in mind there's 5 files at least for every spatial data set. So you're really dealing with folders. So I keep my spatial data in a separate folder by itself so that I don't accidentally mix things up. Because I might have multiple versions of a file, something like that. So really think about spatial data as being a folder rather than a file. So the 5 basic files that you need to plot a shapefile, which is the Esri form, I'll use for the Esri format name, are .shp, .shx, .dbf, .prj, .shape, .xml. This is just like if you have a PowerPoint, it's like .pptx. You have an rdataset, .rdata, for example. So I'm going to go through each of these and talk about what do they actually represent in the spatial data, because you still have these features with any spatial data set, but here they're all just thrown everywhere. This would be like if I had a different file for every variable in my data set, right? That's ridiculous. I don't want 200 data sets to deal with, enhanced data that I have. I want them to all be in one file. Okay, so first we have the shape.shx. So the shape is actually that's actually the real meat of the file. It's sort of what the shapes are, what the polygons look like, what the dot looks like. SHX is a workaround they did because they programmed it poorly in the 80s, the 90s. So they made an index of all the features so the computer would go faster. You still need it to run. DBF is actually just the data set. It has all the data for each polygon. So how many people live in each area? What's the average income in each area? Stuff like that. That PRJ is projection information. Talk about what this is, but it's how do you map a flat map to a spherical world? Right, maps we look at are flat. You probably had a globe when you were a kid or seen one before. The world is round. Hopefully all of you have learned that. Be honest over this class if you haven't, but please talk to me if you're not aware of that fact. I can give you some resources. But so this is solving the problem of the world is not, we can't understand a round thing on our computer screen or on paper. We have to find a way to squish the Earth down. The method of squishing is called a projection. Most of the time, you don't need to understand how it works, except knowing that the projections have to match. If I'm going to make maps or plot things, I have to squash the world in the same way on both data sets to get it to match up. So if things aren't working, it's usually a projection is wrong. If you check that you have all the data files, still not working, it's problem 2 is projection is wrong. And then .shp XML is metadata that could be documentation for your data set. So imagine if your whole academic and professional career, every time you send a Word file, there has to be 5 files you have to give the person attached in an email. You gotta click through and download all 5 files, and then you can't double click on one to open it. You have to go into Word and go to File Open every single time, right? So this is why it's a bad format, but hopefully we'll see some ways to improve this. All right, so what is in a geographic data set? It seems magic when you plot this stuff, but there's a lot going on behind the scenes. It's not actually that complicated. First part, which Esri stores in the shapefile, SHP, is what actually are the coordinates of the data set. This is just how do I plot the shapes on a map. So all it is basically just a little data set that has one variable that's the x coordinate and one variable that's the y coordinate. Might have another variable that says what shape do I belong to, something like that. But it's all about, this is only geometric information. So if I was going to represent this shape here, does anybody know what shape this is? Actually, no, I think it's just a quadrilateral. I don't think it's a rhombus. Not a trapezoid. Anyway, so if we're gonna plot the shape, I'm trying to get those geometry wheels turning. It's been a while for me. So we're gonna plot the shape. All we have to do is think about what are the corners, and we're gonna draw a line between corners. So if you've seen a map, not everything is this simple, right? It's not all just parallelograms, but I promise you, it actually just is. They're just really complicated shapes. Like it's all just straight lines. Even when they look curved, it just means it's a bunch of little tiny line segments. And if you think about how they make spatial data, this has to be true. If you have a map of counties or of districts or of zip codes, somebody went and put a stake in the ground at each one of these corners. You know, if you ever looked at property deeds or something, or property boundaries for a house, there'll be an iron pipe buried in the ground. And that iron pipe is this coordinate. And your house property or the property of the school or whatever is determined by thinking about, well, there's a hypothetical straight line between the different rods in the ground. That's exactly how we do it with GIS data, except these days, instead of putting a rod in the ground, we have a little handheld GPS machine, essentially your phone, and you press the button and it writes down exactly where you are and saves it. So spatial data will always really be constructed from individual points. Even when you see people using those laser rangefinders on a tripod, all they're doing is they're sighting a point in the distance, and they're measuring the angle and the distance to it to estimate where that point is in the world. You don't have to go around to each point and measure it. Also because lasers are more accurate than GPS. GPS is accurate, but you're talking to a satellite or multiple satellites, so there's going to be some error there. Laser beams, you have more control over how it works. All right, getting a little bit off topic, but so it's just a bunch of polygons drawn with points. Here's the projection, which is the other part you understand. This is, how do you go from points on a sphere to points on a flat surface? How do we make the map? So this is like, if you've seen a picture, I'm sorry I don't have a slide of this, but I can bring it up later. If you see the picture of, maps where Canada's really big or Greenland's like the right size, those are all different projections. There's ones where you look at the Earth from the bottom, and so, there's ones where the United States is at the middle. There's ones where they intentionally don't put the U.S. at the middle to remind us of imperialism, right? So keep in mind that projections have this kind of meaning to them, but for our purposes, really, it's not going to make a huge difference, but they have to match. You have to have squashed the Earth in the same ways for both data sets to get them to line up, because you're usually going to want to plot multiple things at a time. In general, there's 2 types of data sets. There are two types of projections and coordinates. There are geographic coordinates, which are like those you get from the GPS. These are basically on the sphere. They either use an accurate model of the Earth or a simplified model of the Earth as a sphere to give you real spherical coordinates. That's what latitude and longitude are. Then you have projected coordinates. These will be on the ground. I have a laser beam and a survey tool. I'm going to measure how many feet apart this thing is. For the most part, you want to deal with projected survey coordinates often you start with geographic coordinates. So you have to convert the geographic ones into projected coordinates using a projection. That's all going to be done for you. You just have to make sure that the projections are the same. So every projection has a name for the way that you squash the Earth to make sure that that's the same for both types of data. And all you do is you convert them if they're different. The computer will unmatch the Earth and then rematch it the other way for you. You don't have to worry about doing anything that yourself. But be aware that you have to do this to make it work. The final piece of data I'll talk about is the actual attributes of the geometry. So this is just a regular data set where each row is either a polygon or one of those points. And this has what would be normally in a data set. So I might have, if this was census blocks, it's just like little units, little neighborhoods. Might have the area in square miles. Might have an estimate of the exposure, like the toxins in that area, and the number of cases that appeared there. And also want population to be able to standardize it, so I don't just so it doesn't just look like I have a lot of cases in some areas. So just a brief overview. There's other junk with the shapefile. It's not really that important, but make sure you don't delete it. All right, you'll run into problems. You're going to share this with somebody who only works in ArcGIS down the road. They're going to panic because they can't recreate the ArcGIS file. So please just keep all the trash that goes along with it. You know, it does something. It's not super important, but just keep everything with you in the data set. Put it in some folder is what I recommend. So put it in a zip file. So we're going to practice using QGIS a little bit. This really nice point-and-click interface for making maps. You often use this to actually make something you would look at later. R could do a lot of the spatial analysis and data processing and stuff, but if you're going to print out a map for presentation or something, you often want to do it. So how does R handle spatial data? We're going to use the SP package, which is built around handling Esri files and other types of files. It organizes things a little bit differently, but all the same components are there. The benefit to you is that everything can be wrapped up in one data file, one object. The object type is called a spatial data frame. There's a version for points, there's a version for polygons, there's a version for lines. There's one unified piece. That's going to be like your data sets were before. And you're going to access parts of that object using the ampersand, not ampersand, this is the @ symbol. Have you all used the @ symbol yet in this class? I can't remember. For an object orientation. It works just like the $, except it's just for spatial data. So you use it to get into the data set. So if I wanted to get to the polygons part of my data set, I would write, my data @ symbol polygons. Just like if I want to get to a variable in a regular data set, I would put data set $. Let me write an example of this. So if I want to get out, most of this is behind the scenes, but it's important to understand what's going on. R will handle this for you. Just like if you get a summary of a data set, it'll automatically pull out all the variables it needs. So if I had my data ampersand polygons, this will pull out just the polygons part. And I can use all the other things I know about R queries to pull out individual parts. So if I only wanted the first polygon, so like the first unit, I could just put in, I'll show you how to find out this later, but I could put in 1. Because as it turns out, the polygons are just a list of individual polygons. So I can say pull out the first polygon. Another example would be, what if I just want the data set? I'm using a package that can't understand spatial data. I only want the underlying data set. Well, I can use this data tree over here. You can look at this using the stir function, our str. If I want to pull out the data, I could say my data, which would be my spatial data, @ symbol data. This is going to look just like a regular data frame to R. And I can further pull out stuff from this using $, right? So it works the same way. You just use @ to zoom into different parts of it. You can see here that we've glued together all the different parts of the Esri shapefile, but we have the same components. We have polygons, we have data set, which is the attributes from Esri's format. We have the projection, which are, hopefully, it's just a text string. You can deal with like any other kind of text. Proj4 string. Proj4 is a name for the open source way of doing this. Started using other programs. VBox is the bounding box. It's the the maximum extent of your map, kind of like the limits of the map, just like the limits of the graph. That helps you plot it, helps you do other analyses faster. Plot order is a little bit technical, but it's saying, okay, I've got all these points here, or shapes. To do something, I got to figure out, they have to have an underlying order to organize them, just like a data set has an observation order, right? So this is like kind of saying this is observation 1, this is polygon 1, observation 2, polygon 2, that kind of thing. So you can use its parts and access the parts using brackets for $. So the benefit of R is if you have the right packages installed, most of the stuff happens behind the scenes. You don't have to worry about it. So you'll be able to use the same commands that you did before with the packages installed, and R will just automatically translate for you. It's seamless. So if I want to make a map, all you do is you just use plot, and it makes the map for you. It's very simple. There's other ways to do it. I think Mike will show you some ggplot methods, which can be an improvement if you prefer that style of coding. You sacrifice some control over way more flexible and easy to do options. And similarly, you practice using different objects. Spatial data works the same way. So if I want to make buffers, which is like, okay, draw a circle around each area. Maybe I want to know how many grocery stores are within 3 miles of my study participants. I can make a buffer by using another command that takes the spatial object as a function. So you can do this kind of operation using ArcGIS or QGIS with menus, but it's way better to do in R because it's reproducible, it's going to go faster. If you make a mistake, it's easy to fix. People can copy paste your code. There's all these reasons why it's better, but just keep in mind that you're going to be able to do most things either point click or R, but it's your choice based on how much you use it. As a side note, you can look this up if you're interested, but the new approach is using spatial features in R. This hasn't got a lot of traction, but Mike could point this out to me. And essentially, spatial features is just a data. It sort of turns the idea around. Before we had spatial data, and inside of that is a data frame as a part. The way simple features works is the spatial data is just one of the variables in the data set. This kind of makes intuitive sense to most of us having worked with data sets a long time. You just have a column that says spatial, and in that spatial variable is all the spatial information stuck in as one variable. The computer doesn't care how big the variable is, but we have ways to look at it and interpret it in a straightforward way. The benefit of this is we can use it with all the things that we're used to. It's really more simple. But it's not quite out there. You're never going to get a special simple features data frame. People are always going to ask for the shapefile. Sort of get used to the thing we're with. But when you one day have the ability to pick something different, please do pick something. So we're going to practice with the remaining time. We're just going to practice putting together and opening up spatial data. We'll do more stuff with this on Wednesday, but I just want to get you all back towards doing something with this. So I'm going to work with QGIS first. So if you downloaded that, go ahead and install it. And please feel free at any time, just branch off, do your own thing, look up your own stuff. But I just want to sort of go together and show you how to get there. So I'm going to install QGIS if UNC will let me. Find out. I'm hopeful because it's giving me the ability to say yes. All right, the defaults are all fine. If you want to put it somewhere, that's fine. Built-in data, but I'm not going to bother. I like looking at the terminal output. It's comforting to me, but if it's not comforting, please hide it. But just sort of telling you what's going on in case there's a problem. I want to also make sure I have my spatial data ready. So if you look in the data pack for the class, just put this on the desktop here. All right, if you look, so here's our data set we started with. But if you look in the maps folder, Mike has used the same approach I do, which is putting everything in one folder, right? So here's all this hideous, underground, behind the scenes files here. If I try and open one without doing anything, like let me open the database file, Windows doesn't know what to do. But because I know what this actually looks like, if you tell it try anyway, if it will come up, and you open it in Notepad, well, look, here's all it is. It's just someone figured out how to do this in like, late 80s, and this is what they came up with. There's like a certain number of spaces between each column. But like imagine trying to import this in, you've imported stuff in SAS or R from text files. Imagine trying to do this, right? Like you got to figure out how this whole thing works. It's terrible. But we can also look at the other files using Notepad. Let's see if it'll select. So usually if you open stuff in a text editor, you can look at 95% of files, what's going on behind the scenes. So you'll notice here's how Esri treats projection information. So I can make this a little bigger for you to see while QGIS is loading, but
All right, where are those files that you're?
so these are in. So if you go to the good question. If you go to the EPI 799C course website, the learnr.web.unc, it's in the NC burst data that you can download from there. Within that zip file, if you download it, there's a folder called maps, and inside that maps is all these different files here.
Okay.
Good question though. Yeah, I don't want anybody to just get stuck and be like, oh well, I'll do this later. Just please ask me. Somebody else will probably have the same problem. So if I look at my projection information, you'll see here's the name of my projection. Here's the datum, which is the starting point. This is, again, you don't really know this. Spheroid is like how they did the squishing. What I use for the prime meridian, what's the units, right? So it's all this junk in here, but just make sure it matches. You'll be able to do that with the command in R. You don't have to worry about it. But if you ever need to, you can look it up here. I think that SHP might actually open in Notepad too. The point of doing this is I just want to demystify this for you. People, talk up GIS and as it's so complicated and special, but really it's hard because people have done a bad job at it in the past. So just be able to look and see what's actually going on. All right, this one's actually a binary file, so I get gibberish. So Notepad's doing its best, but they've got some other kind of encoding here. So you would never really deal with this. It looks cool. For Matrix. If you need to make a movie about the Matrix, just open up some. Let's see if this will open up. And then I will sort of go back to QGIS. So this, I think, is an XML file, so this should be human readable. No, they've done some kind of non-ASCII encoding here. So theoretically, this should have been readable because it's, but they chose not to do it, probably to make it harder to reverse engineer. So much like SAS, some things are easier to reverse engineer because everything has to be backwards compatible. So they can't add layers of protection for their own software. Anyways, I'll talk about that later if you're interested. But it looks like I should almost be done here. So QGIS is a very simple program. It works if you've ever used Google Earth or even Google Maps. It's really the same kind of idea. Looks like we're actually getting stuck trying to make the shortcut. So, it was not okay. So probably had trouble because we're on some kind of protected environment here. All right, so once you open QGIS, it's going to take a minute the first time. Got to load all this background stuff. It's going to be a very simple window. You're going to have a middle part that shows your map. You're going to have stuff off to the side that shows your data set. Let me see if I can. I'm just going to see if I can make this any bigger before we get started. Maybe not easily. So I'll just have to try and narrate carefully what you're supposed to do. All right, so the first thing we need to do is load our data. Again, we have to do it from the program because the format is split across different files. But this is just like any other program. You're going to go to Open. So project. So it's a little bit glib there. So what we have to do is we have to import data, just like we have to import data in R, just get closer to it. Because I might have multiple files presented at once. So if you go to the project menu, this is going to be like the project file that sort of it's saving what you did to all the data. But we actually want to import an individual data piece. So you're actually going to layer. So we're going to make a layer of data. That's going to be like importing one data set. Then I'm going to say add layer. So I'm adding data that already exists. And then add vector layer. So vector layer means that I'm using that point-to-point information. A raster layer is if I have a grid. So I know from before having looked at this data that it is a vector data. anytime you have a shape file, it's going to be vector data, essentially. I'm going to add a vector data. Then I'm going to click Browse to look up where my data is. And I'm going to navigate to where I put it. So I put mine on the desktop in this maps folder. And I think it'll actually work if you click any of these, but I usually just click the .shp file to point it to and hit open. All right, so you'll have a map like this. So I'm gonna make sure everybody's here because you'll be able to play with this as long as you have this in system. You all have pointed and clicked enough in your life. You can figure this out, I'm confident, but it's getting started is the hard part. So I'm gonna spend like 3 or 4 minutes to make sure everybody's got something open. If you don't want to do it today, that's totally fine. So don't feel bad if you don't want to work on it. But I'm just gonna make sure everybody, if they need help, can ask me. If everybody's somewhere, so please call me out if you're having trouble. Yeah. Okay, so you might have to just open it again.
It's open. I just
Oh, it is open. Oh, you might have. So if you right click on or 2-finger click on NC counties down there, there should be some option like zoom to extent. Click zoom to layer. All right, let me show you that. So you can scroll around and hit all kinds of hotkeys to zoom around this map. You know, you've probably heard Mike is a big fan of hotkeys. I can't type, so I don't use hotkeys a lot. I like the mouse. I think it's one of the great inventions from the 70s. I don't actually remember when they first made it, but so you can roll the mouse wheel to zoom in and out, and you can at the top there's a little hand you can click on, just like when you look at a PDF. So I just think of maps as really they're just PDFs you can play with. You click the hand at the top, you can drag around your map and zoom into different parts on the fly. Eventually, you're going to get to a point where you're lost. So like, I don't know where I am right now. I've gone on a journey to the Pacific Ocean or something. What you can do is you can right click on, you'll see in the bottom left is a list of all your data sets. If you right click on the layer, you can click zoom to layer to reset your view. So another way you'll have this happen is if you have 2 data sets with different projections, you have one of them projected wrong, so all the points show up in the Atlantic Ocean. It's in there, but you don't see it. You can click zoom to layer to see if it's what the projection problem is. All right, so just a couple other things to point you towards more point and clicking. If you right click on the layer, you're going to have all the options available to mess with it. And there's all kinds of things you can do pretty simply here. You can change the color. You can look at the data. But what I want to show you is just sort of what everyone does. So let me show you. We want to change the color of each block based on the property of the data set. This is how everyone wants to do maps. It's called I always pronounce this wrong, but it's either chloropleth or chloropleth map or something. It looks like chlorophyll, but it's not. It always trips me up. But all it means is, and you can look up how it's actually spelled, but all it means is I'm coloring it based on some code here. So this, I'm used to this custom setup that I have here, so I gotta remember what all the default options are here. All right, so if you click on the little tool brush, I think it's a little paintbrush or something on the bottom left in the layers panel, you're gonna come up with your color scheme options. You know, this is like changing the color of stuff in your PowerPoint. But you'll notice, okay, so the boring part is I can just change the color of the whole map, right? But like nobody wants to do that. We want different colors for each square to get something interesting. But what I can do is notice at the top of the color dialog, I have different coloring options. So right now I have one symbol for everything, but I can also say, do I want categories? Do I want it to be graduated? Do I want it to be rule-based? Do I want to do some other kind of cool thing? Do I want 3D mapping? I'm going to pick categorize. This is how I recommend you do most data. I always like the idea of having graduations because, I can show the actual continuous variable, but in epidemiology, we often want to do grouping of people, so it's usually good to use groups. You can read more about this.
Sorry, what did you click on to get that menu?
Oh, okay. So in the bottom left, there's a little paintbrush as one of the icons from the layers panel in the bottom left. I think you can also get to it if you right-click on the layer name and hit. This is what I was looking to before. Actually, I just have an older version of QGIS. But you can also click properties there. Just right-clicking properties, and you'll have the same dialog under style you can click on. It's just do you prefer a sidebar or do you prefer its own window? I usually prefer the own window, but whatever's comfortable for you. So what you want to do here, so let's just make a really simple color-coded map. And then I'll confirm everyone's, you know, I promised I'd do it for everybody, I forgot. So let me do this and see if everybody has a map to do this. So pick categorize. And then you're going to choose a variable here. You can pick anything you want. So I clicked on column. You just can see all the data in here. I'm going to pick preterm, just as a, you know, whatever is fine for you. What we have to do is, okay, we've picked a variable. We have to tell QGIS how we want to do the rule about colors. This is kind of simulating recoding for you, but it does it on the fly here. So you're going to click classify. So this window here shows me what my legend is going to be. If I click classify, it's going to generate, by default, some kind of symbol color scheme. If I hit apply, it's going to do it. Now, this is a very bad example because it thinks that this is every different number is a different color, which is a bad idea. But look, you got a colored map. You're 95% of the way there. You just got to fiddle with the widgets to get it looking like you want, right? You can have a great map to show people. So let me go around and see if you can play with. All you have to do to make it not silly is change. Let's see, advanced. Well, see if you can play with it, because I'd rather get everybody started with this, and then we can play with the options later. But see if you can get a map that has different colors. You know, whoever can get it meaningful first gets the prize. But you know, that's not gonna be me today. But you know, try and remember the button you're gonna need is the classify button to get started. You're gonna have to classify. It's gonna automatically pick something, and you can edit it. It might actually be easier if you hit. Let's see if this is an easier button for all to use. Might be easier to start with. All right, so I started with the color ramp. This is how you can fix this one problem. The color ramp is how I do the colors. There's a menu for that in this menu. By default, it does this rainbow of different things for everybody. But if you pick one that has a meaningful color scale, now you can see in my little table here. And I got this by hitting classify, bottom left.
Wait, the display is messed up.
Oh, did I? Whoops. How did I? Somebody like hold it. What have I done? I must have hit the. Nothing spelled. Okay, let's see. Well, play with yours while I fix this, and we'll see if we can get. I'm going to start a video conference. Okay. So again, to fix this, you can change the color ramp, which is the way they do the colors, to something different. Like here, I'm using Magma. Sounds cool. But if I apply for Magma, all right, now I've got a public health looking map. So the hot spots here are going to be the more preterm birth. Now I'm going to circulate and see if we can all get here, and then I'll show you how to put some. The final things I want to cover today is putting like a north arrow on here to give you a minimal map and a scale. And then we'll import this into R to play with next time.
How did you pick a variable to look at?
There should be. So for column, for some reason yours is cut off. It hit that on column. There you go. And then I had preterm was like near the bottom.
Oh, right there. Okay.
Oh, you might.
No, sir.
Why do I have a different version of the data? Yeah, I thought I used the one. I used the one from the website, so it should be. You might have to re-download it. I'm not sure.
I opened this one.
Counties with data.shp. Huh. Wait, move. This is NC County, so I think it actually somehow is the wrong file. Yeah, so try adding another layer. Second layer.
Oh, I did that one.
Yeah, so Mike kind of did what I did, but he put both of them in the same folder. So be sure that you got the one that says with data when you import the file. So there's.
I did the stable version.
Column
Yes, yeah. Is the newest version.
Yeah, so make sure you get the one that says with data when you import it.
So it might not have magazines.
Look at that.
The more exciting the name, the more exciting it is. I like that about this. All right, so you're good.
I lost it.
Yeah, because.
I've got something.
One,
Do you have like a legend format? I don't know.
Let's see. You can tell by looking at the bottom
Right
left.
now.
If you pull over this window by clicking on the column next to it, this one might be. No, that should be the right file. Try doing the properties and then click on. You should be able to change the simple fill on the top. What happens if you click on simple fill?
I tried.
Oh, yours, for some reason it's displaying weird. So it's actually this whole thing is one. So click like this arrow on the top left. I'm not sure why it's doing that. And then click on categorize. Yeah, it's
Okay, that's-
I've never seen that before. So it might be some new
I also
thing.
don't know why these are so tiny.
Yeah, I
It's
don't get
just
it.
loading data on my computer. It's hard to
Yeah, this-
Yeah.
yeah, I've never seen that before. I don't-
No, it's like a fancy like display.
Yeah, that's what I'm thinking. Sometimes they'll scale it down. Yeah. Yeah, sometimes if you have a really good display, it's if you have a really big display. It's like,
Yeah,
oh, you've got like a 4K resolution. Of course you have like a living TV. And then it makes it extra tiny. So that's probably, that's what I would guess.
Wait, so sorry.
Yeah, so you've got it as categorized. So you're gonna let it try first. Oh, sorry.
Just that.
Click the-
Oh, yeah. No, let's
I haven't got
Like,
it.
like,
This is just tax.
And then hit classify or try.
It would be a.
Now you
You
can
got-
change
I didn't call it.
which is this really long.
Well, you can see this one. Yeah, that's
Right, and then pick something that's like a spectrum.
So you have to make sure
Right now,
that you're,
and then hit-
like if you're already at, that they have it.
right, and then hit- You should get a-
Oh, okay.
So Mike will talk more about the theory about this tomorrow, but just, try and get something working today. So you can do it in the future.
I want this to be
So what did Mike use to create this shape file? Did he use R to?
Yeah, so he used R. He just used R to merge the two together. So he used R to open the existing shapefile, he used R to open our data, and then he connected them based on the county ID. So I was hoping to have time to do that today, but I want to. So does anybody else? Yeah, me.
That's
Make sure everybody's up to date.
everything the other ones. None of this actually. Here we go. Greens. Greens. You get pre-turn. You get pre-turn.
Oh yeah,
Like,
so try right clicking on it. Yeah. Close that first because you can only handle one. All right, right click on that and then click zoom to layer at the top. That should reset it. All right, and then try right clicking on that. See, you've got both. Oh, I think I should. So you've got both data sets displayed. Click the X on next to the purple one. Yeah. All right, and now change. Right click on that. And put 0 to 10. Yeah. All right, and then right click on it again. Try setting the color options. Hit properties. And style, pre-term. All right, hit classify.
Maybe I got it.
And then hit apply.
Oh, it was working.
Let's hope that. All right, cool. So you got something. All right. Does anybody else have nothing and they want something? All right. So you all should have a map or know how to do a map in the future if you want to do it today. So I just want to show you two more things. At this point, you can point, click, explore everything. I honestly don't read tutorials. Don't buy a book. Just have your data and just click on every menu option. That is the fastest way to learn this. It's very simple. But I just want to show you two to get a complete map. Number one is getting a north arrow. This is a little bit counterintuitive, and let me see if they've improved this. Because you need a map needs this. It needs a legend, which I don't have yet, that tells me what the colors mean. Right? This is meaningless right now. And I need a north arrow to show me what orientation the map is in. We all recognize North Carolina, but some people may not know what it is. So we need a north arrow, and we need a scale. All of those things help people interpret our maps. So in general, let me see if they've added a feature to do this for you. But what you want to do is, okay, this is our map. It looks great. We're going to move to our print view. So what you use is something called Print Composer, which is like your setup for your map. we're all kind of like zooming around in here. We don't really want it so that we have to zoom to a specific place to make our map. We want to be able to edit our map and stuff and still have our output kind of look the same. So what we do is we can click on Print Composer, and under the Project menu, we go to Project and then New Print Composer. And then unique title, okay, my map, whatever you want to call it. All right, so this is going to be how we actually prepare our map file or our map document. So again, this is kind of like Google Maps. If you could change the world just by point and clicking, right? You can change how Google Maps works. This is I'm like trying to print out. The Print Composer is like I want to print the map. I want to send. My grandmother can't read. She doesn't use computers. I got to send her a map of how to get to my new house. So I got to print out a Google Maps map to give to her. That's what this is, right? The Print Composer. So what you have to do is, it's the same idea, get the map in, is number one. So the buttons at the top will add individual pieces to your map here. It's just a matter of finding the right one. So this has been changed since I used it last. So there's going to be, so under layout now, you can add, so see how fast, like I haven't used this in like a year, and I can just find it immediately because, it's point and click, right? You just look for it in the menus. Don't be intimidated. You can't ever break your data in here. In general, QGIS and ArcGIS are not going to overwrite stuff unless it's really going to warn you if it's going to overwrite something. And if you're really scared, just make a backup copy. So you're going to go to Layout in the Print Composer and click Add Map. Nothing seems to happen. What you have to do is you have to draw the map with a little crosshair that appears. So I want my map to take up this red box worth of room. So I'm going to draw that and release, and it's going to make a map appear. Notice how it's still kind of garbage, right? I have to do something still. But what this is doing is it's kind of like creating a virtual picture that I can play with to make my final map. So I'm going to drag this box until it kind of represents how much space I want to use. Now I need to fix the position of the North Carolina, so I'm going to click on this button. Wait, is it this one? Yeah, move item content. So just play with the tools on the left side here. The one that shows you having arrows in a map that says move item content if you mouse it over, that's what's going to move your map around within the window. See how it stays inside of this little window I make? So what you want to do is you want to think about what the layout of your map is first, and then you're going to try and move the content around to make it look good. All right, so let's say I'm going to do this. I'm actually going to change. There's a way to do this easily. I want to kind of make one that looks like North Carolina, so I'm going to change the dimensions of my page. Right now it's a letter, but I'm going to just change it to well, don't worry about that. There's a different way to change the dimensions, but it's sort of giving me paper by default. You can always edit this in custom program. All right, so I've got my map here. The next thing I want to do is I want to add a north arrow. Let me see if they've done this easily. All right, scale bar. So let's do scale bar next because that's easy to find. If you look on the tools to the left, there's one that looks like a little scale bar. All right, it's the same process. I'm going to draw where I want it to be, and it's going to pop up here. So just like PowerPoint or Word or any other interface, I can right-click on individual pieces and change them. Well, actually, in this one, it's on the right here, but notice in the bottom right, there's this window that says composition and item properties here on the bottom right. If you click on item properties, that gives you the menu for any particular piece. So I can, let's say I've got this in kilometers, because QGIS is, a lot of people work on the project from Europe, have a lot of meetings over there, so they're into meters, as is most of the world, but I want feet. All right, so now I've got it in miles. All right, that's good enough. You can change the spacing of the thing. Just play with it. You can figure it out. Now, the one that's not obvious is how do I add a north arrow? Oh, they added it. Thank goodness. Thank goodness. All right, so they added the ability to put an arrow. You used to have to paste in clip art. It was really janky, but it's really great now. So you draw where your arrow wants to go. And, this one's kind of bad because you can edit. So this is actually just an arrow. This is not north. So there's a way to actually add which way is north here. But for now, just, make an arrow. You can learn how to do the thing later.
If you press shift.
Oh, yeah, this will actually make it. This is, yeah, if I know, whoops. If I know my projection, what have I done? Let me start up. If I know my projection is aligned so that north is up, I can just add a right? I can hold shift and add it. Put my north there somewhere. All right, so I'm almost done. The other minimal thing I need is the key to my map. So I can, again, there's a button over here to the left, right above the scale bar that says add new legend. I can drag this somewhere. Now notice that it automatically matches what my graph is. So what you really want to do is you want to be editing the way your graph is displayed and not editing the label here. So like I wouldn't want to change this so that, because I actually have all these colors, that's the problem. So what I want to do is let's say, okay, my legend is too complicated. I want to go back to my original map, back on the main window. Notice that my print composer stays up in the background. I can save that as its own thing if I want to. But go back to my map, I'm going to hit properties. All right, I don't like the way that it did the categorization. So what I have to do is I have to change where they move this to. I want to change the way that it's doing my symbol coding here. So if you notice on the bottom right of the style window here, there's a button that says advanced. Click on symbol levels in the little window that appears. That's going to take you to, there's an easier way to do this, I haven't done in a while. There's a way to set what kind of breaks it has. If I can find the right. Oh, you know what? I've done continuous. That's the problem. So, what am I missing? What did they try and make easier for me that I'm overthinking? Ah, here we go. Okay. No, that's not quite it. That's the coloring. What I want to do is change the actual categories. Oh, that's really weird. They don't have. There must be some option I'm missing. Anyways, I can get back to you at this, but we'd want to change the categorization so that it had meaningful colors.
I went to color ramp. I went to edit and changed it to screen.
Oh, there's like this edit.
Yeah, and at the top instead of continuous, I did.
Okay, so they did. They tried to make it more intuitive. I'm just being counterintuitive. So thank you. So if you go to, they actually compress this into one option, the color ramp. They used to be two separate things. If you hit edit on color ramp, you can change it from continuous to discrete, and then you can see the things appear here, and you can drag them around. And then you should be able to set. Let's see if I can. All right, categorize. Should be some option here somewhere to. Well, I'll get back to you on that, but I encourage you to play around with it. Try and figure it out. So in the last, I think I ran myself out of time, but I just want to show you quickly how you would import stuff into R. And then that'll set us up for R really not on here. Sorry, y'all. Here's R. I'll just use the console version. Just to briefly show you, and feel free to leave if you need to, but there's a couple packages we'll use. We're going to use the SP package, which handles spatial data. So I'm going to call SP. All right, other packages that are helpful. All right, so we've got SP. The other packages we'll need are RGeos and RGDAL. These tools together will do most of that lifting for importing stuff for you. So if you just install all these packages, these three, it's going to do most of the stuff you need. And the approach that I use is there's so many points to go wrong in importing data. You don't know what the person's give you. I take a step-by-step approach. So I start with inspecting the data set that I have. Let me libraries. I can get a plot here in like 5 minutes to show you all. So I've got my library set up. The next thing we're going to do is have autocomplete. I'm so reliant on RStudio. Let's look up the command. So there's a command in one of these packages called OGR info. OGR info, which I can never remember how to spell. What OGR info does is it reads, so it's in GDAL. Remember we had RGDAL, it's just the R version of GDAL. What OGR info does is it looks at a file and tells me what it is and if it looks good. So practically what I do from the R program, I'm going to say OGR info, and then I'm going to put in the path to my file, my spatial data file. So I'm just going to, normally I'd set a working directory, but I'm just going to try and do this a quick way. I'm going to get the path for if I tell it DSN is like the folder that it's in, layer is the layer name, that's going to be the name of the file.
Are we loading the map we created or just the data?
Oh, this is like the underlying data. Yeah. I've got the name of all the files. It's just NC counties data. So if I'm lucky and I run this, oh, I gotta reverse my. Again, we'll have some code for this on Wednesday, but. Oh, it's on my desktop. Oh, there. Okay, so the I in OGR info is capitalized. I'm used to relying on RStudio, but so what's going to happen is if I successfully run OGR info, DSN is saying the data source name, and that's what the folder is. Layer is what the actual data is called. If I run this, it's going to give me an overview of what's in the data set. I use this to confirm the data set's working. That's step one, is OGR info. So I can look, okay, it's got 25 fields. It has all the stuff I think. It has this projection. The CRS is coordinate reference system. It tells me the extent of it, everything. So I'm just going to check to make sure it's something works for OGR info. The second command, I apologize, I'm going to look this up in Studio, which is could be read OGR or something. Yeah, read OGR. Read OGR works just like read.csv or read.das, whatever you want to use. We're going to use the same format as OGR info. I forgot to tell it, save it somewhere. All right, so I'm going to call this map. So map equals read OGR, my file path, and the name of the data. All right, so I've got the map, and now I've got the map inside of R, and I can just do whatever I want with it. So just you want to today, what I would try and get to, or when you go home, it's just try and get the map out of the door. So R will do the same kind of thing that QGIS will do. You're gonna set the options using commands to the point. Like it's the same idea. So once the map's in, you can do merging, you can do subsetting. I'll often do subsetting in R because it's easier. You can then re-output your files to another shape file. So if I wanted to say plot map where map $, preterm is greater than mean of preterm. I'll give this as the final. Oh, I need a in floppy here. All right, so you can see I can subset my map and only plot some of it. Right, so if you really wanted to, you could plot. I could combine some to make a really simple color map using base R commands. You won't really do this, but I could plot all the maps, all the counties with high preterm in red. Right, so this would be. Oops. Not what I want. Here we go. Oh, I probably have to add it. That's true. All right, so here, here's the simple R approach. There's more island ways to do this, but this is the minimal map in R. You essentially use the same thing you learned with making other overlay maps with base R. You can just plot. You can plot the map, in one color of the background, and then plot different colors individually based on subsetting. This is all QGIS is doing for you. It just does it. Hopefully, you can see why it's going to be easier to do that. So thanks all for staying a little bit over. Sorry it took so long, but we'll go into more of the R side stuff on Wednesday. But it's important to have sort of a feel for what's really data. QGIS can also do that. So any questions? All right, thanks, y'all.